Okay. Hello to everyone. My name is Moises Lodeiro Santiago. I'm a degree computer engineer from Universidad La Laguna, and in the last month I have finished my master's studies, and now I am PhD student in Universidad La Laguna. Also, I'm working as researcher in the same university in the cryptography group. Now I'm going to present the project that I've made for this edition of Google Summer of Code 2016. This project is called IBRI, that means Interactive Beacon Rescue Interface. After this little introduction, were given to me along this period. The problem that we want to solve in this project is due to the fact that in last years, a lot of people have disappeared. This represents a big problem for the society because usually it's very costly in time and money to find missing people. And in the world of case, unfortunately, some people never appears. Because of that, I present for this Google Summer of Code edition a novel solution for this kind of emergencies, which is based on new technologies like physical web beacons and drones to replace the actual methods on searching and rescue operations. On the one hand, physical web beacons, as we know, are devices that use a new Bluetooth low energy system that are continuously sending a wireless signal with some fields inside, like an URL that can be used for user identification. On the other hand, our project is ready to use unmanned aerial vehicles, also known as drones, which can be controlled either remotely by pilots or autonomously onboard computers. Some of the actual proposals in search and rescue protocols are based on simple communication systems to alert to an emergency team using, for example, the GPA's position. Those systems usually requires for a user interaction to alert to the squad by using an emergency call, even when the smartphone have no coverage in the area. This is possible at least in the European Union since 1991, because when a user dials the 112 phone number is able to use any mobile operator independently of the operator or the smartphone. In the IBRI project, the first hypothesis is that where the person is don't have coverage, or all the mobile operators or the network infrastructures are collapsed or unusable, or directly there is no network available. The second hypothesis is that the user could be unconscious or that the smartphone is out of battery. In comparative with other SAR methods, our works as the possibility to use a low-cost and automated method to find missing people instead of using specialized pilots that can control the UAP combined to the physical web beacons using the Bluetooth Low Energy. Also, we provide a practical and secure remotely interface to control the mission on the fly. This allows to the search and rescue squad to be focused and informed on each step of the mission. The IBRI project is composed on two different parts. The first one is a web platform that allows to an operator to create a new search and rescue mission. To manage the data, create a KML file that can be loaded into a drone and see the past mission. The second part is the Android and mobile application that will be loaded in the smartphone that will be carried over the drone. Now we will see a proof of concept, a real-time demonstration, where I will be showing the steps that have to be followed to correct use of the project. Okay, first of all, we will see the administration panel. This panel is programmed using Django 1.9 as framework server, using Python as main program language and SQLite 3 as main database language. The queries to the database are made using an object relational mapping to work with class models instead of using an SQL queries. The frontend has been made using HTML5 as markup language and CSS3 as style sheet using material design as a style. Also, I have used jQuery to manage the JavaScript. As we can see, we are using an HTTPS connection to provide security to our data. This is the administration panel. First, we have to log in because if we don't have access, we can't go in. So okay, this is the administration panel based on material design, as I said. On the left column, we have the different sections that will allow to an admin to manage the data. The first option that we will see later is a link to the operator panel where we can create a new mission. The second option is the client options. As we can see, we can list them or create a new one. For this demo purpose, I have created some dummy data. As we can see, this quick view allows to an operator to find the most important data for a user. The most important data here is really the URL that will be stored in the physical web. As we know, web official application, when it is installed in a smartphone and detects a physical web URL, the application opens and shows a little description as notification. So the beacons that are in search shows a alert message like this, as we can see in the screen. But if the physical web is not in search, nothing appears. Okay. First of all, before going to a track or excursion, the main idea is that the ones who want the service have to register their data and the physical web beacon on the system. This will be nice, for example, if done in a scale by a local or national emergency agency. Until now, we have talked about user data, but which user data is registered in our system? When we create a new user, we register some fields that could be useful for an emergency squad. Those fields are the first name, last name, email address, an identifier, and the allergies, city, mobile phone, postal code, allergy, diseases, the blood type, and if the user is in search or not. And the physical web URL that will be stored in the Bluetooth devices is created automatically by the system using the Google Shortener service when the user is stored in the database. The data is stored in an encrypted database using an AES-256 CBC block cipher. Then the third option is the mission option. When a user click on this section, we could see a list of the mission that we have done. Also in this section, we could resume one mission, or if we lose the connection with the main panel, and see the results of any mission. For example, here is an example of the view a past mission. This is a mission that I've done yesterday. This is the signal beacons, and those are the photos that the mobile took. Now we will see how the operator panel works. When we access into the operator page, we can see two separate panels. The top one is just an information panel. On the left, we have the logo type and information about which mission are we playing. In the middle, we have an icon that shows us that we are using an HTTPS connection. And then at the top right, we have the button to go back to the main area. In the center of the page, we can see an interactive Google Maps with two icons on the top right. The first one is where the climatology will be shown, and the other one is a button that displays the user list in search. For example, I will check Moises as person in search. Well, what happened when we click over a map? When we click over a map, at first we can see the climatology in that area. Appears a square grid point. This grid represents the area where the drones will fly to search the beacon in search. Although we can use, we can see a red point with a drone symbol inside. Point is where the drone will lift off. Then at the bottom of the page, we have 4 sliders. Those sliders are used to configure the searching area size, the number of drones in flight, the distance between the points, and the flight altitude. Then we have a small checkbox to ignore the climatology conditions. When we click on play button, the clients make a petition to the Open Weather Map API as we to inform us what is the climatology in the area. If, for example, it's raining or the wind is over 10 kilometers per hour, we will see an alert message and the mission will be aborted. For this reason, it's really useful, that checkbox, because if we consider that the climatology is good enough to fly a drone, we can uncheck it and ignore that restriction. So we select the Moises. This is the URL that I have set in my physical web beacon. If we change, for example, the grid size, the point will change. Also, we can change the grid size. Well, when we select the users that want to find in the configured area, we can click play. This will send a request each 5 seconds to the server to refresh the information in the map. After click that button, in the map now we can see many routes as drone we selected. The server now has generated an optimal route using an A-star algorithm following the travel in search problem. This route is represented also as KML file. This KML file is also used as link to Mark Gonzalez GSoC 2016 project named PILT. That project handles the interactive visualization of the drones in Google Earth using Google Liquid Galaxy technology. Now we will see the other part of the project, the drone application, developed in Android. As we can see, the drone application has a simple interface. The start button triggers the background service that initializes the detection system. Above it, we have a log console where the log message will be displayed. And then we have 3 text boxes. The first one is to set the route to the server. And then we have a password text field. This is very useful because if the HTTPS protocol is broken, as it happened recently with the protocol, we have an extra security layer in communication. And then we have a drone ID. This field represents the identifier for each drone in the mission. For example, if the mission has 2 drones, the first application should have 1 and the second the number 2. Now we will click on now I'm turning on the beacon because now it's turning off. Okay. And start service. As we can see, the smartphone has connected to the mission, the same identifier. First of all, the smartphone will connect to the server. And I will also emulate. Okay, it's connected to the server and check the connection. It's correct. Then the smartphone will download the mission and the identifiers from the beacon. Now we can see the drone in the map. here. When the smartphone detects the signal, it takes a photo. Now you can see it's like a streaming. Then compress it to the base 64 string, and then the smartphone sends the photo to the server. Also, the drone obviously sends the GPA's position well, obviously we can see the results we show. I will stop the service. Those are the photos that takes and the place. And as I said, the backend of our application is using an object relational mapping linked with a SQL database in the Django. The database has been encrypted using a Google library named KCSR using an AS256 algorithm to cipher the database. And that's all. That thanks one more time to my mentors, and thanks to Google for letting me being part of this Google Summer of Code 2016. It has been an awesome project and an experience, and I hope that this project could save human lives in the future. Thanks again.